by multiples of 10. So you might have divided by 10, right, Dylan? Or 20, 30, 40, and so on. Today you're gonna have two-digit divisors. So what you're dividing by, it's gonna be any two-digit number. So is it going to necessarily end in a 0?
No.
No, it could be 38. It could be 57. But it will be two digits. So, but your quotients are just going to be one digit. Think of a situation where you guys might use division. Grace.
When separating something?
When separating something, okay? Exactly. Give me a scenario, Alex.
When you're at Walmart,
Okay, what might you do at Walmart?
like when you buy something, but like they don't count it on your, like on your receipt.
On your receipt?
Yeah, on your receipt, and then you write down your checkbook, you're gonna have to divide that
By the number of items. Okay, so you might have a total amount, and you could divide by the number of items. That won't give you an exact amount for every item. It'll give you an average of each item was about this, or an average. Okay? That sort of, but really?
There's like little things that come on napkin, and I know there's 30 of them that go all
Okay.
over the place, and I don't know how many groups there are. I know
If you wanted to put them in groups, you could use division. Okay. I'm going to give you guys a scenario. And I don't think it's in your book, but it's in my book. It says, suppose you have 250 yards of string to fly kites at a festival. The string comes on bolts, or a ball of string, of 75 yards each. How many bolts of string do you need to buy? How would you start to solve that problem? What process could you use? Wyatt? Division. If we want to know how many 75s, how many groups of 75 will it take to get to 250, we could use the operation of
multiply,
you could multiply.
or we could take 250 divided by 75.
Exactly. 250 divided by 75.
Can we work that out?
You can write those down.
Okay.
Now, we're just going to use long division to solve this, but you might be thinking to yourself, and one thing that when I see a division problem, I automatically think the inverse. I think of multiplication. How many 75s will go in to 250? What could you do to help you start this problem? Something we've already talked about. We talked about earlier this week. Aaron? Okay, we could do some guess and check. Okay. Dylan?
I think it's 1,007.
Oh, don't tell me an answer yet. What else could we do that we've already learned about?
Guess and check.
Guess and check. What if we used compatible numbers? 250 is kind of hard to divide by 75, but what else do we know about using compatible numbers that might help us? Grace?
Like take off the 0 and change it.
So we might have 250 divided by 50. Would that be easier? Because we know that 5 can go into 25 5 times. So 50 goes into 255 times. That kind of gives us a starting place. It's not exact, but it gives us a starting point. Or what if we said 280 divided by 80? There's another set of compatible numbers. that?
Divided by 7?
70, yes,
Yeah,
you're
yeah,
right,
she's
divided by
right.
70.
The 8 was 70.
Eraser. Okay, so that would give us a starting point. 7 goes into 28.
4 times.
Let me just try to get rid of that.
I should probably go. Okay, 4 times, so then 4 times 70 would give us 280. So those would give us starting points. Which one do you think is closer? Probably the 250 divided by 50. But let's go ahead and divide to find out. I would never try to divide 250 by 75 with it written horizontally. You're always going to solve going vertically. Okay. Now, we did some compatible numbers to estimate to get a starting point. And I'm thinking, well, maybe 5 is close. Okay? Can 75 go into 2?
No.
Can 75 go into 25?
No.
So we're going to start all the way over here with the ones place. How many times does 75 go into 250? Well, we're thinking maybe 5 is close. So let's check. I'm going to do guess and check with some of you suggested 75 times 5 because that's kind of my starting point from my compatible numbers and estimating. Okay, let's check it out. 5 times 5 is 25. 7 times 5 is 35 plus 2, 37. 375. Guess what?
Too big.
Too high, so we need to back up. Let's try. This did not work. Let's try 75 times. If we're backing up, what would I multiply by? 4. Let's try 4. 5 times 4 is?
20.
I want to hear everybody. 7 times 4 is?
28 plus 2 is 30. That's 30.
Ooh.
Too big.
Too big. Still too big, okay? So what do we need to do? Desiree? Desiree, what do I need to do? If 5 is too big, 4 is too big, I think we should multiply by 75 times. These were too large. They gave us a product that was bigger than 250. 5 was too large, 4 was too large. What should I try? 3. Okay, now that's smaller than 250, but if we go up, it's too large, so we need to use this number, right? Because we can't be larger than 250. So 75 times 3 is 225. Dylan Summerlot, what's my next step?
You need to divide them.
I divided, now I multiplied. 3 times 75 is 225. What's my next step?
Subtract.
Yes, subtract. Borrow, regroup. I have 25 as a remainder. Is it okay to have a remainder of 25?
Yes.
Why, Brody Baker?
Because 25 is not greater than 75.
Right. My remainder is less than my, what's this number called? Divisor. So I have 3 remainder 25. So that would tell me that I need 3 full bolts of yarn, and then I need 25 more yards, because remember 1 bolt was 75 yards, so, or not yarn, but string for the kite. So 3 full bolts, and then they'll need a 4th one, they'll need part of it, right? And we'll get into fractions later, but they'll actually need 1/3, because 25 times 3 is 75. Okay. Let's watch.
So guys, Mrs. Haas already said this, but we are not, in some lessons, you know, it tells us to estimate, to round, to use compatible numbers. We're finding the exact answer. We're finding the exact answer here, but we use compatible numbers and things like that in the beginning to help us know where to start.
Yeah. It helps you with that guess and check, that process of guess and check. Oops. Some words I think you already know, but let's division.
Division.
That's the process we're using. And remainders.
Remainder.
It's what we have left over. I always think of it as the extra, the leftover.
What are the steps for dividing by two-digit numbers? Think about this question during the lesson. A theater sold 428 tickets for a show. A section in this theater has 64 seats. How many sections must there be to seat all the ticket holders? What operation should you choose to answer this question?
So when you think of division, think of you have a total. The total in this case is 428 tickets. How many seats? How many groups? So you would use division. Oops.
Divide to answer the question. How would you set up this problem? Set it up as 428 divided by 64. What are you trying to find out?
What are you trying to find, Hope?
How many seats do they need to seat 428?
Okay.
How many seats are in the theater for the people?
Okay. Corinne?
How many groups of seats that they need?
Okay.
You are finding out how many sections are required to seat every ticket buyer. Estimate to help decide where to place the first digit in the quotient.
If we estimate 428 is close to what? Can't see who. Wyatt?
130?
Okay. Think about compatible numbers. Whose hand over there? Brody.
420.
Okay. And our divisor 64 is close to?
60.
Okay.
428 divided by 64 is about 420 divided by 70, or 6.
So we're going to estimate that there's about 6 sections of 64 seats.
Divide the ones.
Was our estimate close?
Yeah.
Yeah. How many seats are left over?
46 remainder.
So there's 6 sections that have 64 seats, and then one section only has,
44.
right.
There will be a remainder. What does a remainder 44 tell you? You must add one more section onto 6 sections to accommodate the remaining 44 ticket seat holders. Check the reasonableness of your answer.
Notice how they check their answer. Use the inverse operation.
So the theater